Here's another differential equation problem that we're going to solve. It's similar to the previous example, but a little bit more involved because instead of giving us the first derivative, they're giving us the second derivative, f double prime of x equals 8x cubed plus 5. And they're giving us two initial conditions. The function evaluated at x equals 1 equals 0, and the function's derivative, f prime, evaluated at x equals 1 equals 8. And then they ask us to find the original basic function, f of x. Okay, and we're going to find the particular solution, so we're going to make sure that our arbitrary constants have actual numbers for it. Okay, let's go to step 1. Step 1, first we're going to find the most general form of the antiderivative of the second derivative, f double prime of x. Okay, so listen up. What is that going to be? What is the antiderivative of f double prime? This will be f prime of x. This is what we're going to find. And why is that true? It's because f prime of x is the function whose derivative equals f double prime of x. So finding the antiderivative of f double prime means we're finding f prime. We're moving down one level. So f prime of x, let's figure out what the antiderivative of 8x cubed, that will be, let's see, add 1 to 3, bring it down it'll be 8 over 4 times x to the 3 plus 1, 4. And then the 5 is plus 5x, and don't forget the constant plus c sub 1. I'm using the formulas for the antiderivative here. Doing it quickly, so you might want to pause it and go look at the note that shows you the formulas. Step 2, find the most general form of the antiderivative of f prime. Now we have f prime. What is the antiderivative of f prime? It will be f of x. Why? Because f of x is the function whose derivative equals f prime. So they're asking us to find f of x. Okay, find the antiderivative of what we have in the cloud in step 1. That 2x to the fourth, the antiderivative is 2 over 4 plus 1, 5 over times x to the 4 plus 1. And then the 5x is to the first power is 5 over 1 plus 1 times x to the 1 plus 1. Then plus c sub 1 times x plus c sub 2. Okay, that's f of x. Now we have to get rid of all these c sub 1s and c sub 2s. First, let's use f prime of 1 equals 8 to find the first constant, c sub 1. What does f prime of 1 mean? Look at the f prime formula in the cloud for step 1 and evaluate it at x equals 1 and set it equal to 8. That gives us 2 plus 5 plus c sub 1 equals 8. Solve for c sub 1. 7 plus c sub 1 equals 8. So c sub 1 is equal to the number 1. Thus, we can replace c sub 1 in the cloud formulas for f prime and f of x in steps 1 and 2. So f prime of x is equal to 2x to the fourth plus 5x plus 1. And f of x is equal to 2/5 x to the fifth plus 5 halves x to the second plus 1 times x plus c sub 2. Step 4, use f of 1 equals 0, the other given information, to find the other constant, c sub 2. We're almost finished now. So evaluate the f function that we found in step 2 for x equals 1 and set that equal to the other side, which is 0. That gives us 2/5 plus 1 times 5 over 2 plus 1 plus c sub 2 equals 0. Okay, at this point I'm going to go back and make sure those 1s, which I screwed up on those, they look like 8s, but they're supposed to be 1s. Make sure those are all 1s, okay, because c sub 1 was equal to 1. Continuing, we have 2/5. We got to get a common denominator here of 10, so we have 4/10 plus 25/10 plus 10 over 10 plus c sub 2 equals 0. So we have 39/10 plus c sub 2 equals 0, and that means that c sub 2 is equal to negative 39/10. Yeah, okay. So what does that mean? We're going to put that into the step 3 version of f of x. Our answer is f of x equals 2/5 times x to the fifth plus 5 halves times x to the second plus 1 times x is x minus this c sub 2 we just found, minus 39 tenths. And that is the function that satisfies all the conditions in the given information. Again, we have solved a differential equation. That's what it's called, what we just did. So we did it in the previous note, starting with f prime of x, we found f of x. Here we took it a step higher. We were given f double prime of x. We had to find two different antiderivatives, find two different constants before we were able to bring it all the way down to the original function f of x.